Welcome to This Explainer. Today, we're diving straight into one of the absolute most critical concepts in C programming, repetition. We are going to completely master C loop structures. So whether you're looking to optimize a really complex algorithm or you just want to completely ace your upcoming exams, you are in exactly the right place. Let's get into it.
Here's our roadmap for today. We've got 1. The power of repetition. 2. While and do-while loops. 3. Mastering the for loop. 4. Break, continue, and go to. 5. Switch statements and nesting. And finally, 6. Recap and exam guide.
Okay, starting with Section 1, the power of repetition.
All right, picture this. Your instructor hands you an assignment. Write a program to find the average of 5 numbers. Easy, right? Piece of cake. But what if they suddenly changed it and asked you to average 100 numbers? Or what about 1,000? Seriously, how would you write a program to average 1,000 numbers using just basic sequential statements? Just think about the sheer pain of trying to scale that code manually.
Without loops, your code would turn into an absolute unscalable nightmare. You'd literally have to declare 1,000 individual variables. You'd be sitting there typing out every single one of them inside this massive scanf statement, and then painstakingly writing sum equals num1 plus num2 plus num3 all the way to 1,000. No way. The real magic of computers is their ability to do repetitive tasks instantly. And when an action is repeated over and over, we call that control flow a loop.
So let's look at the basic taxonomy here. We essentially have 2 flavors of repetition. On the left, we have counter-controlled repetition. This is definite. We know exactly how many times the loop is going to run before it even starts, kind of like counting from 1 to 10. It just needs a control variable, an initial value, an increment, and a final test condition. Now, on the right, we've got sentinel-controlled repetition. This one's indefinite. We don't know the exact number of iterations in advance. Instead, the loop just keeps chugging along, processing data, until it hits a specific sentinel value, basically an end-of-data flag.
Moving on to Section 2, while and do-while loops. When we look at a while loop, the control flow comes down, and the very first thing it hits is that diamond right there, the condition. It evaluates the condition before the body of the loop is even processed. If it's true, we run the block, loop back up, and test it again. But here is the absolutely critical part to remember. If that condition is false right out of the gate, the loop body doesn't execute at all, not even once.
Connecting that flow to the actual C syntax, the structure is super clear. First off, you initialize your loop counter outside the loop. Then you drop in your while keyword, followed by the condition in parentheses. Inside those curly braces, you've got the statements you actually want to execute, and, crucially, your loop counter increment. Honestly, if you forget that increment step, congratulations, you've just built an infinite loop.
Now, contrast that with the do-while loop flowchart. Check out the visual flow here. The diamond, our condition test, is now sitting all the way at the bottom. The flow dives straight into the do-while block, executes the code, and only then does it stop and ask, hey, should I do this again?
Because that condition gets tested at the very end, a do-while loop guarantees that your loop body is going to execute at least once, no matter what. Looking at the syntax, the do keyword opens the block, and the while condition wraps it up at the bottom. And hey, notice that trailing semicolon right after the while expression? You definitely want to remember that. It's required syntax that structurally sets it apart from a standard while loop.
All right, Section 3, mastering the for loop. And this brilliantly illustrates why the for loop is so wildly popular. The anatomy of a for loop header lets you pack all 3 essential components into one single, clean line, instead of scattering your loop control all over the place. Right there, inside the parentheses, strictly separated by semicolons, you get the initial value of your control variable, the loop continuation condition, and your increment.
So the key here is really understanding the exact chronological order of how this executes. Step 1, the initialization step runs first, and it runs exactly once. That's it. Step 2, the condition gets evaluated. Step 3, if it's true, the body executes. And finally, Step 4, the flow jumps back up to the header to run the increment statement before looping right back to Step 2 to test that condition all over again. Mapping out the execution flow demonstrates exactly what we just talked about. Notice how the initialization, setting the counter to 1, sits completely outside that repetition cycle. It happens one time. From then on, it's just a tight, continuous cycle between testing the condition, running the printf statement, and incrementing the counter. Visualizing how these variables change over time, that is the absolute secret to writing flawless loops.
Next up, Section 4. Break, continue, and go to.
The direct contrast between these statements is incredibly important for controlling your flow. If you drop a break statement inside a loop, it triggers an immediate, total exit from that entire structure. Boom, you're out, and the program just moves on to whatever code is next. Continue, on the other hand, is a bit less dramatic. It simply skips the remaining statements in the body for that specific iteration and jumps straight to the next cycle. Oh, and the source material also mentions the goto statement, which passes control literally anywhere in a program without even testing a condition. But honestly, modern structured programming generally avoids goto entirely because it can make your code impossible to follow.
Let's move to Section 5, switch statements and nesting.
Consider throwing a switch statement inside a while loop. Say we're reading characters to grade an exam. Instead of writing out this massive, tangled web of if and else-if statements to check for A, B, C, and so on, the switch statement cleanly evaluates each specific case. But definitely notice the break statement tucked inside each case. Without that break, your code would just fall through and erroneously execute all the cases below it. Not what you want.
Now, when you start nesting actual loops inside of other loops, there is a vital rule you've got to understand for performance. The inner loop must perform all of its iterations from start to finish for every single iteration of the outer loop. So if your outer loop is set to run 5 times and your inner loop runs 5 times, the code sitting inside that inner loop is actually executing 25 times in total. It scales up fast.
And finally, Section 6. Recap and exam guide.
Okay, definitely memorize these bullet points for your exams. First up is the catastrophic off-by-1 error. If your loop is supposed to run 10 times, but you accidentally type strictly less than 10 instead of less than or equal to 10, it's only going to run 9 times. Second, and your instructor emphasizes this heavily, never ever use float or double for monetary loops or precise counters. Floating point values are just approximations in memory, so they can cause inaccurate loop terminations and totally mess up dollar amounts. Third, never drop a semicolon immediately after a for loop header. It essentially turns your body into an empty statement. And lastly, just always remember to use curly braces if your loop body has more than one statement.
Just to quickly recap our core concepts before we wrap up. All definite counter-controlled loops need a start, a test, and a step. Remember that while loops are pre-test, do-while loops are post-test and guarantee at least one run, and for loops, they just centralize all that beautiful control logic right onto a single line. You now officially have the full power of iteration in C. You know exactly how to make the computer do the heavy lifting. But I'm going to leave you with a bit of a challenge. Based on what you now know about how these structures actually execute under the hood, could you rewrite an entire nested loop program using only a single loop and a clever switch statement? Think about how that control flow would work. Keep experimenting, keep coding, and definitely use this explainer as your guide. Thanks so much for joining me today.